In this video, we are going to explore event-driven architecture, a pattern where components communicate by announcing things that have happened rather than calling each other directly. It is one of the most powerful tools for building systems that scale and change independently, and it shows up everywhere from payment platforms to logistics networks. Imagine an e-commerce checkout. When an order is placed, you need to charge the customer, update inventory, send a confirmation email, and notify the warehouse. If the order service calls each of those directly, it has to know about all of them. Every new requirement, say, adding a loyalty point service, means changing the order service itself. The system becomes a web of direct dependencies that is fragile, slow, and exhausting to change. Think about how a newspaper works. The journalists write and publish a story. They do not know or care who reads it. Subscribers simply receive whatever they signed up for. A new reader can join tomorrow and start getting the paper without the newsroom doing anything differently. Event-driven architecture works the same way. One side announces what happened, and anyone interested reacts to it. There are three key roles in this pattern. The event producer is any service or component that notices something worth announcing. An order was placed, a file was uploaded, a payment succeeded. It publishes a message describing that fact to an event broker, which is the central intermediary. Tools like Apache Kafka or RabbitMQ fill this role. The broker holds the event and delivers it to every consumer that has expressed interest. Producers and consumers never speak directly. The broker stands between them. Here is how data actually moves. The order service completes its own work and then publishes a single event, call it order.placed, to the broker. The order service is now done. It does not wait for anything. The broker persists that event and fans it out to every subscribed consumer. The payment service picks it up and charges the card. The inventory service picks it up and decrements stock. The email service sends a confirmation. All of this happens asynchronously and in parallel, and the order service knew nothing about any of them. Event-driven architecture shines when many services care about the same fact, when each consumer needs to scale on its own terms, or when a burst of work needs to be buffered before processing. The cost is real though. Because steps happen asynchronously, the system reaches consistency eventually, not instantly. So if a consumer fails midway, some data may be temporarily out of sync. Tracing a bug across multiple consumers and a broker is also significantly harder than reading a single call stack. When you adopt this pattern, a few habits pay large dividends. Name your events as things that already happened, past tense, because an event is a fact, not a command. Make the payload carry enough context that a consumer does not have to call back to the producer to understand it. Always attach a correlation identifier so you can trace a business transaction across many services. And design your consumers to handle duplicate delivery safely, because brokers can deliver the same event more than once. To summarize, in event-driven architecture, components communicate through a shared broker by publishing and consuming events. No direct calls, no tight coupling. The producer announces what happened and moves on. Any number of consumers react in their own time and at their own pace. That decoupling is powerful, but it comes with the responsibility of designing for eventual consistency and investing in observability so you can trace what actually happened across the whole system.